Okay, so in this video, I will be going over the material that many of you are not in a classroom to participate in today. But you have homework to do for tonight. So this video might help you to complete the homework. So we'll be working on transformation of square root function today. Transformation of square root function, okay? That's the title right there. And we will be applying whatever we learn from square root function to the other parent functions. So we get started now by looking at square root functions. So if you were in class yesterday, you will notice that we made a table similar to this table over here, this table that I'm circling. So what we did basically was trying to to plug in different numbers for square root of x. So when x is -4, we found that it was not possible to take square root of -4 on on real numbers. So it's an imaginary number. Square root of -4 is imaginary. Square root of -1 is imaginary. But square root of 0 is 0, and square root of 1 is 1. Square root of 4 is 2. And so we went ahead and plotted those points. So here are the points plotted, and we connected with a smooth curve, and we have the parent quadratic function plotted right here. So anytime you want to plot quadratic function, that's the graph. Now we're going to work on transforming this equation today. All right, so let's look at some other modifications to this equation. All right, if you compare what I have here, this one I'm highlighting in blue. If you compare that to, let me zoom a little bit for you to see better. If I compare that to the parent function, this is a parent, y equals square root of x. You will notice that the x has been modified. Okay, so that means the input to this function, the input, the x is the input. We have transformed the input. Here the input has been changed. So here is a transformation of input. So here is input transformation. Because the x has been modified to become x minus 1. Every time we modify x value, this is x, we make it x minus 1, we are transforming the input. That's what we're really doing. So, but if we change the equation and the x is not changed, then we are transforming the output. Let me show you what I mean by that. So this is input because the x is changed. Over here, the x has not changed. The x is just x right there. But there's an additional number on the outside. See that one there? That is an output transformation. So if you take note of that, it's output because the input is not affected. This is output. Output transformation. Okay. We're going to go quickly through a bunch of them for you to see the difference between input and output transformation. The second one to my right here, the x is not changed. The x is just the same as x. So it is not input, it's output. Okay? Output is changed by 1, by -1. All right? If you go over here to the top, here, x minus 1 is changed. I think I should use blue for input transformation. So it's changed. X becomes x plus 1. That's input transformation. All right. Basically, I think that should be clear enough. Let me see if there's more examples here. So all of this transformation down here, x is not changed. That's output transformation. Output transformation. X is the same. Hopefully you got it. Here the x is changed. So x is changed. This is input transformation. Input transformation because x becomes 2x, x becomes 1/2 x. So now let's go back to see what happens when we have input transformation. All right, let's see what happens to the table of values. All right, pay attention to what is going on with the table here. I am trying to get an output value of 0 using this changed input. So I needed to put a number for x, so that when I plug in that number and I subtract 1 and I take the square root, I want to have 0. So that will get you thinking. If I put 0 there, that's not going to work, because that's going to be the square root of -1. If I put 1 there, let's see. If I put 1 there, so it will be square root. It will be square root 1 minus 1, and that's square root 0. Yeah, it works. So square root 0 is 0. So I need x to be 1 in order to get 0 as my overall value. Okay, similarly, if I want to get 1 as my output, I need square root of 1 overall. So I need this stuff inside here to be 1. The only way it can be 1 is to make this 2, because square root of 2 minus 1, 2 minus 1 is 1, and square root of 1 is 1. So I need this x to be 2. All right, let's clear up all these annotation. What do I need to get output of 2? What do you think I need, Ashley? To get output of 2, if I want to plug in something for x, so that when I subtract 1 from that thing and I take the square root, I want to get 2. 5. Let's see. So if I do 5, will be square root 5 minus 1. Yeah, so the square root of 5 is 5 minus 1 is 4, and square root of 4 is 2. That's correct. So it has to be 5. That's the idea. So the same way, what do I need to get? What do I need to plug in for x to get 3 after I've taken 1 from here and I've taken the square root? That will be, I want 9. Yeah. If I do 9 minus 1 is 8. Square root of 8 is now 2. So I need to have, if I do 7, that will not work. That will be square root of 6. I need 9s. 10, that will work. I need 10. So that's how you fill out that table whenever you are given the, you are looking for the input, you don't have the output, you just guess and check my work. All right, so we got that. If you do the same thing for this other one, y equals x plus 1, I want the output to be 0. I want 0 here when I have done all this stuff and taken the square root. What should I put there? See, I want something plus 1 to be 0. I want something plus 1, say blank, plus 1. I want the answer to be 0. -1. So let's try that. Let me erase the other annotation. Let's see. Now we're going to try -1. Let's see what happens. So square root -1 plus 1. Yeah, square root of -1 plus 1. That's square root of 0, which is 0. So -1 is x. Right? So if you go ahead and finish all those for yourself, you can pause the video so you can get a maximum benefit of trying to figure it out by yourself. After you pause the video, figure it out, and then come back to play to see what the answer will be. Okay, so now I know 1 plus 1 is 2. That will not, I want 1, so I have to put 0 here. So hopefully you got 0 when you figure it out for yourself. And I want it to be 4, so square root of 4 is 2, and x to be 3 over there. So 3 plus 1 is 4. And I want this to be 9, so I have 1 already, so I need 8. So I need 8. Okay, so we have done some transformation to the input. Let's see how that transformation looks on the graph. Okay, let's look at the very first transformation in which we are subtracting 1 from the input. Let's see how it looks on the graph. So we graph it now. When x is 1, y is 0. When x is 1, y is 0. When x is 2, y is 1. When x is 5, y is 2. Okay, we don't have, let's erase all these annotations. We don't have values for 10, so that's enough for us. We're just going to make the graph and see what happens. So make this graph like this. Make the graph smooth curve. Hopefully you are following along in your packet, so you're getting the maximum benefit from learning from this since you are away from class today. All right, so that is the graph of that. Before we go further, let us go ahead and compare this graph with the parent graph. I'm going to zoom out and see what happens. Oh, if you compare these two graphs, you will see that what's happened here actually. Compare these two graphs.
They have the same shape.
Same shape. What's the difference between them?
One starts at 0 and one starts at 1.
1. So what can you say as far as geometry is concerned? It moves along the x-axis. 1 unit to where? Is it right or left?
To the right.
To the right. So whenever you change input transformation like we just did, the number here tells you how many units you move to the right. So x minus 1 says we have moved 1 unit to the right. It doesn't appear logical, but that's what it is. That's what we saw there. So I want to make input transformation. I want to clarify it and say this is horizontal translation 1 unit right. So go back to your notation and put here and put input transformation. Here is horizontal translation 1 right. I want to emphasize the right because you're going to see what happens with the other one now. It's moving 1 unit to the right. Let's make it bigger for you to see everything. Remove the annotation. Okay. This guy over here represents a movement to the right. 1 unit to the right. That's what it represents. All right. What do you think this one will represent before we graph it? What do you think this one will be? Okay, let's see what happens. Let's try to graph it. You might be right. Maybe 1 unit to the left. Let's just see now. So let's go to the graph. -1, 0. -1 is 0. So let me graph with blue this time. -1 is 0. 0 is 1. And 3 is 2. We're just going to graph 2 points. 3 points is enough. 3 points enough. 3 is 2. So I think you're right. We can see that after we make the graph, let's try to make that bold. After completing the graph, we see that actually that's a movement to the left. It's a movement to the left. So let's go back here and notate this information here for your information that this represents horizontal transformation 1 left. Okay, that's 1 left. The other one was 1 right. So I want to make sure I emphasize the left because it sounds counterintuitive. It's a plus here is moving to the left, but it's a minus here is moving to the right. I have a little illustration for you here to illustrate why is he going to the left. Why is he going to the left? Or why is he going to the right? Actually, I may not be able to do that right now. I'll do it later on. Let's go on and find the other one first. So when it's time to go, just go. I'll finish it and post it, okay? The next one is output transformation. So we're going to plug in some value here for x. When x is 0, square root of 0. So we're doing square root of 0. Square root of 0 plus 1. Square root of 0 is 0. 0 plus 1 is 1. So this answer is 1. Square root of 1 is 1. Square root of 1 is 1. Plus 1 is 2. Square root of 4 is 2. 2 plus 1 is 3. Square root of 9 is 3. 3 plus 1 is 4. So we want to see, what do you think without me drawing this yet? Yeah. What do you think this will be before I even make the graph? It's hard to tell, right? Or what's your guess, your best guess? Movement on the Y, right? You are right, because its output is y is the output, x is the input. So it's going to be some movement on the y. But what's your guess? Where is it going to go? Is it? You remember that y can go up and down only. Let's see. Let's go graph it and see what happens. So go back over here. When x is 0, y is 1. Let's put the graph there.
Maxwell, please report to the main office. Maxwell?
Let's use another color over here. I can use that. Okay. Hello, Iha. Okay, that's part of my video forever. 0 is 1. 1 is 2. 1 is 2. This is fifth period now or lunch? Okay, good. 1 is 2. And 4 is 3. 4 is 3. 4 is 3. Right there. We're going to stop right there. And then make our graph. I want to make the graph like that. Oops, that's not good. Make the graph like from, what am I doing over here? Okay, goes from there. So actually, it is not movement to the, it's not movement to, it's not moving down. It's moving up from 0. So if you compare that to the parent function, the parent functions are 0, but this guy is moving up instead. So, right. So input and output transformation are totally different from each other, what you expect to see. For input is counterintuitive, is going the other way, but for the output is following what you think it should be. So I'm just going to complete it, and you can look at it later. All right. And then the other one, when y equals x squared minus square root of x minus 1, I got to finish this video and post it. I know.
Parts? Making mistakes.
Okay. So when x is 0, you're going to have square root of 0 minus 1 is negative 1. Negative 1. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. Let's go ahead and graph this other one, okay? So it will be 0 to negative 1. Another color. 0 to negative 1. And 1 to 0. 4 to 1. 4 to 1. Okay, so I'm going to make this graph and see what happens. So make this graph. Okay. If you compare this gray graph with the original, with the parent function, you will see that the gray graph actually is like this. It's moved down. It's like this. It's like this. It's shifted down by 1. So let's write the annotation here. Remember, HT means horizontal translation. This one is vertical translation. Vertical translation. Vertical translation 1 up. This one is vertical translation 1 down. 1 down, okay? This is 1 down. The other one is 1 up. So now we got the information we need for today. Basically that. Now we're going to apply this information to the second part of the worksheet, okay? Or actually, let me just give a little quiz on this and then see what you can tell me. What if I have a function like this? If I have a function like this, it says y equals the square root of x minus 8 plus 3. What do you think is happening to this function? Because I have more than one thing now added to it. So you see, it has both, let me put the 8 very well. It has both input and output transformation. Both of them. So in this case, it's moving 8 to the right. So it's horizontal translation 8 right because of the minus 8. And then vertical translation, 3 up. 3 up. So for vertical translation, if it is plus, that means up. Like we found over here. If it's plus, it's up. Up. Let's annotate that. If it's plus, it's up. If it's minus, it's down. So if it is output, that is the y value, is changed. Up means up, plus means 1 up, negative means down. Right, but for input transformation, minus means to the right and plus means to the left. Okay, so what we're going to do now is to apply this to other transformation. The other worksheet that we did in class was this.
Maxwell, if you're in the building, please report to the main office.
This is what we did. So now let's say I have a quadratic function, not square root, and I want to translate it 3 units to the right. 3 units to the right. Let's use blue for right. 3 units to the right and 1 unit down. Okay, we're going to use the same thing. Whatever happened to the square root is same thing for all the functions. So this one will look like this. The parent quadratic is this. This is the parent. Parent is y equals x squared. Okay, this is the parent. Y equals x squared is the parent. So if you're going to move 3 to the right, that means we are going to change the x to x minus 3. So it's going to look like this. Y equals x minus 3 and then squared. What we did was we just changed the x to x minus 3. That's the only way to move to the right. If you are going to move to the right, you change it to minus 3 and then you do 1 unit down. That's the output transformation. You do minus 1. That's minus 1 right there. All right, basically that's it. That's the equation that will represent that. If you do that on your graphing calculator or any other calculator, you will find it's moving actually that way. Let's try it on Desmos and see what happens. So let's go to Desmos and see how that looks. Okay, so I want to type the equation so you can see what I was typing. Type it over here. Y equals, okay, let's put it where you can see it actually. Yeah, let's see. One moment, let's adjust this screen so you can see it. Let's see. Try to move this so you can see what I was typing. All right, I'll just type it and see what happens. Y equals parenthesis x minus 3 and then plus 1 plus 1. Okay, we need to put a square there to the power of 2. Okay, so you cannot see the equation I typed on the left, but actually it's this. I tried to make the screen move, it couldn't move. Anyway, you can see.
Miss Villarreal is back. Please come to the main office. Today is the last day to buy prom tickets.
So
if you're buying prom tickets, please come see Miss Villarreal.
we have moved from the origin 3 units to the right and then 1 up by typing that x squared minus 3 minus 1. I need to make it minus 1. That's minus 1. Oops. I'm gonna put minus 1. Okay, I just changed it, so it's gonna go 3 units to the right and 1 unit down. 1 unit down. So 3 units to the right, 1 unit down. So it worked. It worked. So your goal is to be able to imagine what the graph would look like
Orlando Parra, please.
for other parent functions. Okay, let's do other ones, like for example rational. Let's go to number 3 for rational. So we know that rational function parent is like this: y equals 1 over x. So I'm going to go 3 to the right on that. That means I'm going to change the input. So it will be y equals 1 over x minus 3. I have just changed the x to x minus 3, and then 1 unit down. So minus 1 unit down. And so you will get the same effect. If I graph this, it's going to shift 3 units to the right and 1 unit down. Let's do one for absolute value. The parent function for absolute value is y equals absolute value of x. If I'm going to go 8 units to the right, I'm going to change the input. So it will be y equals x minus 8 is going to the right, and then minus 4 down. Let's do number 6 that way. Y equals absolute value of x is the parent. If I'm going to go 1 unit to the left, that means I'm going to change the input and change it to x plus 1. So y equals x plus 1, and then 2 units down, minus 2. All right, I think it should be getting clearer to you now. Let's do cubic. All right, let's do cubic number 7. The parent cubic function is y equals x cubed. So if I'm going to go 5 units to the left is going to be adding 5 to it. So it will be y equals, replace the x with x plus 5, and then 7, this is cube, and then plus 7. That's the 7 up, not the drink, but the 7 up here. Okay, next let's do one for logarithmic. We know the parent function is y equals log base 2 of x. If it's going to go 2 to the right, we're going to replace the x with x minus 2. So it will be y equals log base 2 x minus 2, because it's going to the right. And then 11 up, plus 11. All right, let's do one for exponential. For exponential, it's going to be y equals 2 to the power of x. That's the parent. And then we're going to move 3 to the right. We're going to replace the x with x minus 3. So y equals 2x minus 3. And then 6 down. The 6 is going to be by itself. It's not part of the x anymore. Okay, let's do one more exponential here. This is y equals 2 to the power of x. 8 to the left means that we are going to replace the x with x plus 8. Okay, y equals 2x plus 8, and then with 5 up. All right, so we can do all kinds of functions the same way with this square root. All right, just make sure that you understand that whenever you are moving to the right, when it says move to the right, you replace with the opposite sign there, opposite. Let's zoom for you to see. Every time it's right, is the opposite. Every time the opposite sign is a minus. If it's a left, like this one, it's a left over here, then it's a plus. 1 unit left is plus 1. That's just the basic idea behind transformation. And it appears the video is very long. Is because you guys were missing from class today. You need to get all of the information, because you have a quiz to take online today. You have a homework to do. So the homework you're going to do online looks like this. This is your homework for tonight. Trying to get to it on Delta Math. All right, here is how it's going to look tonight. Get over here. Transformations. Okay, here we have it. All right. Here's an example of how your homework will look. We'll do this one example. I think you'll be done. Let's see. Okay, I need to adjust my computer so you can see it very well. Okay, so let's just try to adjust it. I think you should be able to see it better now. Let's see. 1 second. Just trying to fit it to the window that I'm recording on. Sorry, you have to deal with a long video today. You were absent from class. Not my fault. Trying to help you out. Alright, here we go. You can see that it's asking you to find to make a graph of the new one. You say, what is this going to be? You notice that is square root of x plus 4 is an output transformation. That means you need to move up 4. The plus means you're moving up 4. It's not an input transformation. So all I need to do is to drag this point and move it 4 up. If I move it 4 up, and basically that is about that. And I do check now. Let's see what happens. When I check my answer, I say yeah, and I should get it right, which I did. And then let's see if it gives you another kind of function. This is cube root. And then this one is an input transformation. You can see that it's affecting the x alone, x plus 1. It's not affecting the y. So it's just an input transformation. You say move it to the left. See the plus say move it to the left. Move it to the left. So we're just going to move it to the left 1 unit. Drag from the center there from 0, 0. Move it to the left 1. And that should be done. And it should say you are right. Which you are right. So the other part of the homework, which we are going to finish up with now, is this other one that is more complicated. This one is saying you are going to move it to the left, and then you're going to move it down. Left 1, down 3. Remember, plus with the input is the opposite, right? Okay. Left 1 and down 3. Left 1, and down 3. Basically, you got it. And now if you do and check it, you should have it all correct. Okay. So I hope this very long video helps you to grasp the main idea and be able to do your homework for tonight. Done.